Water is the foundation of all known life. From the tiniest bacteria to complex human civilizations, it is essential for survival. But on Mars, liquid water is scarce. The planet, once home to vast rivers and lakes, is now a frozen desert. If we are to survive on Mars, we must unlock its hidden water reserves and do so with precision, innovation, and sustainability. Despite its dry, dusty surface, Mars still holds a significant amount of water. The two primary sources we can tap into are the polar ice caps and subsurface ice deposits. Scientists have confirmed that vast quantities of frozen water are locked within the Martian soil, some buried just a few meters beneath the surface. Accessing this water is one of the greatest challenges facing future colonists. Let's explore how humans could extract and utilize it. The Martian poles contain millions of cubic kilometers of frozen water mixed with carbon dioxide ice. While this reservoir is immense, melting it isn't as simple as applying heat. The extreme cold and low atmospheric pressure cause most water to sublimate directly into vapor rather than remain liquid. One proposed method is deploying massive orbital mirrors to concentrate sunlight onto the ice caps. By gradually increasing the temperature, the process could trigger a controlled release of water vapor into the thin atmosphere, increasing its humidity and potentially forming small clouds. A more controlled approach would be direct ice mining. Robotic excavators could extract blocks of ice, transport them to insulated processing plants, and melt them in pressurized chambers, preventing rapid evaporation. This water could then be piped into underground reservoirs for long-term use. But relying solely on the poles isn't enough. For permanent human habitation, we need to access ice deposits scattered across the planet, especially in more temperate regions where future settlements will be built. Beyond the poles, Mars holds extensive reserves of subsurface ice located just below the dusty topsoil. These ice pockets could be a game changer for future colonists, but extracting them requires careful engineering. First, exploration rovers equipped with ground-penetrating radar would identify the most accessible ice deposits. By analyzing depth, purity, and volume, scientists can determine the best locations for extraction. Once an ice deposit is located, robotic drills or heated boreholes can be deployed to extract ice-laden soil. This material is then transported to a processing unit where it undergoes filtration and purification. From here, the purified water can be distributed to colonial habitats, hydroponic farms, and even fuel production facilities.